trigonometrical functions, that is called the trigonometrical functions, that is also in short called as T functions. Now, at first, we are drawing a triangle. Suppose we have a triangle like X, O, Y. And we have that angle as a value, that is alpha. Now we are taking any point P in OY and we are drawing a perpendicular, that is PM to the OX. So that particular triangle is OPM is a right angle triangle. That alpha, that angle alpha is taken as an angle of reference. That means whatever the functions we are declaring here, that is based on that particular angle alpha. That's why it is called as an angle of reference. Now the side that is completely opposite to the angle alpha, that means PM. Alpha is here, angle is here, and it is in the opposite side of the angle alpha. That PM is called the perpendicular. Then OP, the side opposite to the right angle. Already we know that angle is a right angle. So the side OP opposite to the right angle is called the hypotenuse. And the final, that is OM, is the third side, and that one is called the base. So that means we have OM as base, OP as hypotenuse, and the PM as the perpendicular. Based on that hypotenuse, base, and the perpendicular, our trigonometrical functions or the T functions are defined. Now we may draw different type of angles in the different quadrant. Suppose the very first one, it may be like that. Suppose that one is a coordinate system. O, that is our X, Y, X dash, Y dash. So the angle may be in here, that is in that way. That must be perpendicular. So here that one is the right angle. Here the alpha is here, because always we are thinking about the angle from the OX, from the initial side to the revolving line. We know OP is the revolving line, and M, P is here and M is here. So the diagram should be like that, X, Y, when we have the coordinate of P is XY. Another one, suppose it may be like that. X, O, Y, X dash, Y dash. Now it may be like that. P is here, M is here. So that one is the right angle. So alpha means here that one, because the angle of reference is always here. Same as, so if its value is coordinate point is xy, so that one is the x, that one is the y. That may be a very simple diagram like that also. Like that is x, that is y, O is the origin, that is y dash. Now it may be like that. That is P is here, that is our A, that is our angle of reference or alpha. So obviously if it has xy, then you can find that one is x, that one is y. So whatever be the position of P is and the angle of reference, we can draw different type of diagram. The final one diagram also in the fourth quadrant. I am not pointing, but just drawing the line like that. So if that is our P, that is our M. So the angle of reference may be like that, alpha. So if it has the coordinate xy, then that is our x, that is our y. Obviously, that is the origin. So we can say the starting line is the OA, OX, and then the revolving from the OX. So the angle is always XOA, like that. Here A, that one is also the point A. So what is sine alpha? Just think about from that diagram, it would be easy for you. Sine alpha means that is called sine alpha. That is MP, M is here, MP divided by OP. That means according to the angle of reference, PM is the perpendicular, OP is the hypotenuse. So that means the relation is perpendicular divided by hypotenuse. Okay. Now that one OM is X, PM is Y. That means we are writing OM is equal to X, PM is equal to Y, and the hypotenuse is taken as R. So that means OP is equal to R. So we can write sine alpha, that means Y by R, perpendicular divided by hypotenuse. That is the first one function. Second one is called the cosine. That sine is originally called as sine. The next one, cosine. In short, it is called with the angle of reference, that is OM divided by OP. That means base divided by hypotenuse. Now base means x, hypotenuse means r. So sine alpha means y by r, cosine means x by r. Next one is called the tangent, which in short we can say tan alpha. Tan alpha means MP divided by OM. That means perpendicular divided by base. So perpendicular is equal to y and base means x. So tan alpha means y by x. Another three important functions are there. The next one is called the cosecant. Moreover, it can be called as a cosecant. Then, in short, it is called as cosec alpha, which is OP divided by MP. That means hypotenuse divided by perpendicular. So hypotenuse means R and perpendicular means Y. Next two are another one secant, which in short called as with reference of angle alpha. Secant means hypotenuse divided by base. So that means OP divided by OM, or hypotenuse means R, base means X. And final one, that is cotangent. In short, it is cot alpha. That means OM divided by MP, or base by perpendicular. Base means X, perpendicular means Y. So if we look at the thing here once again, sine means perpendicular divided by hypotenuse. Cos alpha means base by hypotenuse. Tan alpha means perpendicular divided by base. Cosec means hypotenuse by perpendicular. Sec means hypotenuse divided by base. And cot means the base divided by perpendicular. Up to that, is that clear?
Yes, sir. Clear.
Okay. Next, proceeding to another one important sum notation. Like if we have suppose a right angle triangle like that, and it is A is here, C is here, B is here. That is the angle A, that is the angle C, that is obviously right angle, and that is angle B. And the sides are C, A, B. Now, if we say that one is the angle, So what is the meaning of sine A? As we know that the sine A means or alpha means perpendicular by hypotenuse. So that one is our perpendicular according to A. That one is our base. That one is our hypotenuse according to angle of reference A. So sine A means perpendicular divided by hypotenuse. So that means perpendicular is here A and hypotenuse means C. Now look at another one thing. If we have cos B, that means the angle of reference B is here. So according to angle B, what should be the perpendicular? That must be our perpendicular according to angle B. Then that should be our base and that should be our hypotenuse. So cos B means, cos means base by hypotenuse. So here base means A and hypotenuse means C. Look at the value with the angle of reference A, which is our sine A, that is A by C. But with the angle of reference B, the value is A by C. So we can say here that sine of A is equal to cos of B. Same as we can say cos of A is equal to sine of B. Another one we can say that is tan of A is equal to cot of B, or another one tan of B is equal to cot of A. So with the angle of reference, we can say for any right angle triangle, the trigonometrical functions or the T functions may change. Next one, you have to remember one thing always, that whatever we are writing here, like sine, cosine, or simply sin, or cos, or tan, always that s, that c, that t, the first letters must be small. Don't write it in capital. That means never write sign like that. Always write small in that way. Next one, we have to remember sine alpha, that does not means sine into alpha. That does not means that sine, cosine, cos, all are operators. The angle of reference is working on that particular operator. So sine alpha means sine of alpha, not sine into alpha. Same as it may not be sine of A plus B. So we cannot write that is not equal to sine of A plus sine of B. That means we are multiplying A and B with sine. Then we are writing. No, that is not possible. Okay. So always we have to remember these four things, very important. Those are called operators. Next one, power notation. Power notation means, suppose we have sine theta, that one is an angle with the angle of reference theta, and we are writing sine theta square. So sine theta square means sine theta into sine theta. Same as, suppose we have sine theta whole cube. So that means sine theta into sine theta into sine theta. More importantly, that sine theta can be written as sine square theta or sine theta cube, whole cube. That means it can be written as sine cube theta. So that means if we have sine theta whole to the power n, so that means sine theta into sine theta into sine theta up to n sine theta. So it can be written as sine n theta. Another one thing, whatever we are writing here, that is according to bracket. So if we have sine theta square, that does not means it is sine theta whole square, or does not means sine square theta. That is the angle here, that is theta square. That means in that case, that theta square is the angle of reference. In that case, theta is the angle of reference. So if we write that one, so we can write it more precisely, sine of theta square, not sine theta square. That can be written as like that, sine of theta whole square or sine square theta, like that. So when the bracket is there, whole bracket, that is different. When only the angle is powered, that is different. Another one thing is here that we called the value of t functions always the same. Like we can write here the values of t functions are always the same for the same angle. That means, suppose we are drawing a coordinate system. That is our origin, that is our x, that is y, that is y dash. And we are drawing the revolving line here. Here we have at first the point P, and we have the perpendicular with M. Now always look here, the angle of reference is theta. Suppose another one point we have taken, that is, suppose P dash. And according to that P dash, we have taken another one perpendicular here. And that is also joining the OX as in M dash. Now, that one is a right angle. That one is a right angle. So if we look here, that means MP divided by OP is equal to M dash P dash divided by OP dash. That means whatever be the sine theta we are writing here. Sine theta means perpendicular divided by hypotenuse. So here, according to that, for the first PMO, that right angle triangle, perpendicular means PM. That one is also divided by OP. Same we have for the triangle, that is for POM, that is for triangle P dash OM dash, that is P by H, or that one P dash M dash divided by O P dash. That one has been written here. That means what we want to say, the values of T functions are always the same for the same angle. Here we have the angle theta is the angle of reference, and according to that we have the sine theta, and same for the other triangle, right angle, that is using P dash M dash, that is the same. If we draw any other angle here also, the result would be the same. Suppose another point H is here. So if we draw, or suppose P double dash, M double dash, that should be the same for sine theta. No problem. Now, whatever be the quadrant we are using here. Last one, when here we are proceeding to the power, that means sine theta. Suppose we have sine theta whole to the power -1. Okay, we cannot write it. We cannot write it as sine -1 theta. Look once again, when we have sine theta whole square, we are writing it as sine square theta. But we cannot write when that is the power is according to -1. We cannot write it as sine inverse theta. That sine inverse theta or sine inverse theta has a different meaning. That is called as sine inverse theta. Already I have said. And that means an angle whose sine is theta. It means an angle whose sine is theta. Never it is to the power. That means if we have sine -1 theta is equal to m, then we can write sine m is equal to theta. That does not mean sine theta whole inverse, because sine theta whole inverse means 1 by sine theta. That is not sine inverse theta. Okay, and that is also true for any other. That means suppose cot inverse x or theta, tan inverse x or theta, or cosec inverse x or theta, like that. Okay, up to that, some trigonometrical functions has been defined. With from very first one, I am once again saying how the sine, cosine, tangent, cosecant, secant, cot, or cotangents are defined using the angle of reference and from the right angle triangle. Then what is the meaning of the power notation, and also what are the values of t functions, always the same for the same angle we have checked. And finally, you have to remember sine theta whole inverse is never sine inverse theta. That is called sine inverse theta. That means that is an angle whose sine is theta. So that's why sine inverse theta is equal to m. That means sine m is equal to theta. Next one, some formulas. Some formulas expressing the relations between the trigonometrical functions or the t functions. The first one is called the reciprocal relations. Here we have cosec theta, that means 1 by sine theta. So 1 by sine theta means cosec theta, or sine theta means 1 by cosec theta. Same as sec theta means 1 by cos theta. Another one we know, that is cot theta is 1 by tan theta. How we can say it? Just check here. When we have the notation that is base by perpendicular is cot, and tan means perpendicular by base. So that's why the reciprocal functions are here. Cosec means hypotenuse by perpendicular, but sine means perpendicular divided by hypotenuse. So that's why the reciprocal functions are, or relations are here. Okay. In words, I am suppose saying only for the first one. In words, you can say like that, that cot theta is reciprocal of tan theta. That is the same as cosec theta is the reciprocal of sine theta, sec theta is the reciprocal of cos theta. Next one is called the quotient relations. Quotient relations means we have tan theta is equal to sine theta divided by cos theta, and cot theta is equal to cos theta divided by sine theta. Suppose we are writing the sine theta is here. Sine theta means we know P by H, that means perpendicular divided by hypotenuse. And cos theta, that is base by hypotenuse. So if we divided these two, we are getting as perpendicular by base, which means the tan theta. That's why tan theta is equal to sine theta by cos theta, and same as we have cot theta is equal to cos theta by sine theta, because cot theta means already we know that is 1 by tan theta, that is the reciprocal. So the first ones are the reciprocal relations, second one are the quotient relations. Now the third one are called square relations. That is also known as the Pythagorean identities. Okay, the first one is sine square theta plus cos square theta is equal to 1. Second one, sec square theta plus, sec square theta is equal to 1 plus tan square theta. And third one, cosec square theta is equal to 1 plus cot square theta. Let we are writing here. We can check here also. Suppose that is our right angle triangle, and according to that, that is our theta. So we have that one x, that one y, that one r. Okay, so our sine theta is equal to, we can write y by r perpendicular divided by hypotenuse. Cos theta, we can write x by r base by hypotenuse. So if we have, we can write here, that is suppose from the sine square theta plus cos square theta, that means y by r whole square plus x by r whole square. Okay, and that is equal to 1. Same as we have the derivation of that particular x square plus y square is equal to r square, we can define it from a circle. Let's check how we can derive it. Suppose, and before that, we have to know another one thing, that is, in the previous class already we had how we can find the trigonometrical value from the arc. Here is also we are finding, that is length of an arc of any circle. And here we have, suppose, a circle that O is the center. Now we have that OX and another line, that is OP. Let the angle defined in between these two, OX to P, is theta. Now we are drawing another one line, that is, suppose OX is defining the crossing the circumference at point A and here at point B, and another line is here, that is C. Why we have drawn it? Now that arc value, length of the arc is R. The length of the arc is R. That means whatever be the length of the radius, length of the radius is equal to R, and arc AC is also R. So whatever we can say that particular angle, we can say it as 1 radian. Already that has been described in the previous class. So according to the angle, we can write, here I am once again writing angle AOC is equal to 1 rad or radian. Angle AOB, that means AOB, okay, divided by angle AOC, that means the radian portion. And already we know that is the same ratio following with the arc. Here that one is the arc, that means arc of AB. Angle AOB means arc of AB, ACB. And another one, that is angle AOC, that means the arc AC. Now here, suppose that arc, whatever we have ACB here, suppose S. So we are writing it as S divided by R. The arc is R. So we can write it from here that angle AOB, that one, is equal to S by R into angle AOC. Now we know angle AOC means 1 radian. So we can write it as S by R rad or radian, because S by R into 1 radian means S by R radian. Now we have the angle AOB means theta. So we can write theta is equal to S by R. We are not writing the rad here, but that implies S is equal to R theta. So that's is the process when we can find out the length of any arc of any circle. That has been described here once again for the finding of x square plus y square is equal to, or the sine square theta plus cos square theta is equal to 1. So we are drawing once again another circle to describe it. And here we have the coordinate system. So that is our O, that is our X, that is our X dash, that is our Y, that is our Y dash. And here we have a point, suppose P that is our x comma y, and we are drawing here the line up to P, and also the right angle or the perpendicular is here, that is N. So if it has the value x, y coordinate point, so we can say that ON means x and that PN means y, and that one is our radius. So from the previous one, okay, suppose here is the point A dash, B, B dash. Just one point is we are writing here. That R is 1. That means the circle is with unit radius. So we have angle AOP is equal to, look, arc AP, that is the arc AP, and that is our angle. Arc AP divided by the radius, that one is equal to theta by 1 or theta. Okay, so here we have ON is equal to x and PN is equal to y. So write down here sine theta means, what is the meaning of sine theta? Now that is perpendicular by hypotenuse. So here we have perpendicular means y, hypotenuse means r, which is value as 1. So sine theta is equal to y. Cos theta is equal to same as x by r, x by 1 or x. Same as tan theta is equal to y by x. Cosec theta is equal to 1 by y. Sec theta is equal to 1 by x. And cot theta is equal to x by y. So from here, we know what is the formula for circle. X square plus y square is equal to r square. Here, r is equal to 1. So we have x square plus y square is equal to 1 square, or x square plus y square is equal to 1. Now look at the value. Y means sine theta. So we are writing here sine theta whole square is equal to 1. And x means cos theta. So we are writing here cos theta whole square plus sine theta whole square is equal to 1, which can be written as sine square theta plus cos square theta is equal to 1, which is giving our square relation, first one. In the same way, we can find out the sec square theta is equal to 1 plus tan square theta, and cosec square theta is equal to 1 plus cos square theta from that particular diagram or from the first one relation. No problem.